Hello friends, in this video we will see what is cross correlation function and its properties. In the last video we have seen autocorrelation function and its properties. So autocorrelation function means finding the similarity of the same function at two different time instants. If we see the similarity of the same process, then it is nothing but autocorrelation function. Cross correlation function means finding the similarity between two different random processes at two different time instants, then it is called cross correlation function. So here we will have two random processes two random processes two random processes x of t and y of t. We will observe the similarity, or the cross correlation function gives the similarity between these two random processes at two different time instants. So that is the purpose of cross correlation function. It is denoted with rxy of t comma t plus tau, so which is similar to expectation of x of t into y of t plus tau. Expectation of x of t into y of t plus tau. Similar to autocorrelation function Whitesense stationarity. So here also, if x of t and y of t are jointly are jointly jointly wide sense stationary wide sense stationary, then the cross correlation function should depend only on the time difference between those two. That means it is given by rxy of tau. So this is very important for a wide sense stationary process. Expectation of x of t into y of t plus tau will depend only on the time difference between at these two time instants, which is nothing but the time lag. So if if expectation of x of t to y of t plus tau is equal to 0, then it is nothing but then both x of t and y of t are orthogonal to each other. They are orthogonal to each other. Next, we will see the properties of cross correlation function. Properties of cross correlation function. First property is like same as autocorrelation function. First property, cross correlation function. In short, we can write CCF. Cross correlation function is an even function or it is also symmetrical. So then rxy of minus tau is simply rxy of tau. Rxy of minus tau is simply rxy of tau. Second one is if x of t is having an autocorrelation function rxx of tau, and similarly y of t, another random process, is having autocorrelation function ryy of tau, then the cross correlation function magnitude rxy of tau satisfies or it is always less than or equal to its value is always less than or equal to product of the autocorrelation function at tau is equal to 0 of x and y. So the cross correlation function value at any value tau not equal to 0 is always less than or equal to square root of rxx of 0 and ryy of 0. Similarly, it also have another relation, magnitude of rxy of tau. Magnitude of rxy of tau is always less than or equal to 1 by 2 into rxx of 0 plus ryy of 0 ryy of 0. And another important property of cross correlation function we have is if two processes, that is x of t and y of t, are x of t and y of t are statistically independent, independent statistically independent, and they are wide sense stationary process, wide sense stationary wide sense stationary process, then we can write rx. In general, what is rxy of t comma t plus tau? Is nothing but expectation of x of t into y of t plus tau, So if they are statistically independent, then expectation of xy, we can write expectation of x into expectation of y. So this is equal to expectation of x of t into expectation of y of t plus tau. And if they are wide sense stationary, so this is, if they are independent, we can write this one. If they are wide sense stationary process, then we can write rxy of tau, and this we can write simply x bar, and this simply, it doesn't depend on the time instant, we can write y bar. So if x of t and y of t are statistically independent and wide sense stationary process, then rxy of tau we can write as product of their individual means. So these are the properties of cross correlation function. So the definition is, or why we will use, or what is given by the cross correlation function is the similarity between two different random processes at two different time instants. So how they are, what is the similarity between two processes at two different time instants? So first property is an even function. Second and three are what are its maximum magnitude, or what are the magnitude of the cross correlation function at any time instant tau not equal to 0, we can find by using these relation. And fourth one is if they are statistically independent as well as they are wide sense stationary processes, then the cross correlation function is simply given by product of x bar, mean of individual products. So this is the definition of cross correlation function and its properties. So I hope you have understood. Thank you for watching. If you didn't subscribe to my channel, please subscribe to my channel. If you found it is very helpful, please share with your friends and classmates. Thank you.